So far, we've only discussed the slope y-intercept form, and let me actually write this out. Slope y-intercept form. Just a refresher, that means we're talking about y equals mx plus b. But there are also other forms that we can write linear equations in that we haven't discussed yet. There's standard form, and that looks like ax plus by equals c, where your a value has to be positive. That's a key part of your standard form. We also have what we call the point slope form. And it's called point slope form because it includes the slope and a point. Right, it's right in the name. So you have y minus y1 equals m times x minus x1, where y1 and x1, those are going to be some actual numbers. Like you'll have y minus a number and x minus a number. And then finally, we have the intercept form. It has some different names. You might also hear it referred to as the double intercept form. That's okay, we're talking about the same thing. This one might be the least common of the four. And it usually looks something like x over a plus y over b is equal to 1, where the a represents your x-intercept and the b represents your y-intercept, which is kind of cool, right? It's kind of a cool idea. So this b here is your y-intercept, and this a here is your x-intercept. Let's do some examples where we switch between the forms, because that's the idea, right? That's what we want to get comfortable doing, is switching from one form to another. And to do that, it's really just about flexing your algebra skills. So let's do some practice. We'll look at some examples here. Number one, let's say I have 4x minus 2y equals 3. So this is your standard form, right? This is in standard form. It's something x plus something y, in this case it's negative 2y, equals some number, in this case it's 3. So what if I want to put this into your slope y-intercept form? What would I do? Well, if you recall, your slope y-intercept form is y equals, and then a bunch of things, right? So the y has to be by itself. So let's isolate for y. Okay, to start, I'll move my 4x to the right. So you'll have negative 2y equals 3 minus 4x. It's the first step. Now I got to get rid of that negative 2. So I'm going to divide both sides by negative 2. Now I'll be left with y equals, and we can rearrange this and kind of shake it up just to make it look nicer. Like negative 4x over negative 2 is just 2x, and then 3 over negative 2 is minus 3 over 2. So I split up the fraction into two fractions, simplified one of them, and then switched them around just to clean it up. So now this is your slope y-intercept form. So we just went from standard to slope-intercept form pretty easily, right? All you have to do is isolate for y. Okay, good. So that's one example. Now, let's say, this is number 2, let's say you have y equals 5x over 2 minus 2. So this is already in your slope y-intercept form, right? But let's say I want to put it into standard form. So I want this to look like ax plus by equals c, right? So the opposite of what we did in the first question. Well, for this one, you're going to want to put your x and y together on the same side and then have your number by itself on the right, your c value. In other words, this 2 here, which is going to change, but the number that's by itself is going to be alone on the right. So let's bring this 5 over 2x to the left-hand side. So negative 5 over 2x plus y equals negative 2. Okay, so already we're making progress. I don't want this number to be negative, and I also don't want it to be a fraction. I would prefer a whole number. So I can multiply all the terms by negative 2 to get rid of this 2 on the bottom. So multiply everything by negative 2. So if I do that, this here will become 5x, this y will become negative 2y, and this negative 2 on the right will become positive 4. So again, all I did was multiply everything on the left and everything on the right by negative 2 to get rid of this 2 on the bottom and to make this positive. Okay? And now this is looking pretty good, right? This looks a lot like ax plus by equals c. The only rule was that a had to be positive. Okay? That was the only rule. So I would say that I've successfully put it into standard form. Okay, let's do another example. Let's say I have y equals 2 over 3x plus 4. So again, I'm in slope y-intercept form, right? It's important to acknowledge where you're starting. And now let's say I wanted to put this into point slope form. So which one's point slope form? That's the one that goes y minus y1 equals m times x minus x1, right? It's that funny looking one. So I want it to look like y minus y1 equals m x minus x1. This is your point slope form because it includes a point and the slope. So how do I go from that to that? Well, the first thing that I would say that we should do is identify what the slope is, right? Your slope is 2/3. That's your m value, right? Your m value is the same. So when we put it into this form, you're going to have y minus something equals 2/3 x minus something, right? Well, what should I put here and here? Well, that just has to be a point. It can be any point. Do we know a point on this line? Well, yeah, we know the y-intercept, right? The y-intercept here, that represents the point 0, 4. So that can be my y value and that can be my x value. So I can put my 0 here, my 4 here. All right, and that's it. That's good enough, right? That's technically point slope form. So what's nice about point slope form is that the point that you have here, or the point that's represented by those two numbers, can be any point on the line. It doesn't have to be any specific point, it can be any point. So this is technically good enough for us. Now if you're wondering where the point slope form comes from, maybe, if you recall, we said that your slope is equal to y2 minus y1, right? That's the rise, over x2 minus x1, that's the run, right? Well, you could rearrange this formula. If I multiply both sides by this denominator, multiply both sides by x2 minus x1, you would get x2 minus x1 times m is equal to y2 minus y1. This is already looking a lot like our point slope form equation, right? You just swap both sides. You have y2 minus y1 equals m times x2 minus x1. This is basically the formula, right? Except x and y are just, a general point, right? It's just x and y. And then these numbers represent a specific point on the graph. So that's where that comes from. Okay, let's do another example. Number 4. Let's do y minus 2 equals 4, x minus 2. So this is point slope form again. Point slope form. And let's say I want to put it into slope y-intercept form. So our y equals mx plus b. Y equals mx plus b, right? Slope y-intercept form. I want to put it into this. How would I do this? Well, to be honest, I think the easiest way would be just to expand what we have here. Just multiply it out. So we'd have y minus 2 equals, let's multiply this out. 4 times x is 4x. 4 times negative 2 is negative 8. Just like that. Now let's isolate for y, because again, in this form, the y is by itself. So I'll just move this negative 2 to the other side. So I get y equals 4x minus 8 plus 2. That becomes y equals 4x, collect like terms, negative 8 plus 2 is negative 6. And there you have it. That's my slope y-intercept form. Okay, let's do another one. Let's say I have y minus 4 equals 5 over 2 x minus 3. So another point slope form, right? This is point slope form. And let's say I want to put this into standard form this time. Standard form. So your ax plus by equals c, right? How would I do that? How would I do this? How would I make this look like this? Well, again, I think we should expand this to start, right? Multiply out this right-hand side. So you'll have y minus 4 equals 5 over 2x minus 15 over 2, right? 5 over 2 times negative 3 is minus 15 over 2, just like that. Okay, now I want my x and y on the left, and I want my numbers on the right. So I'll bring this x over here, so you'll have negative 5 over 2x plus y equals negative 15 over 2 plus 4. Let's put these two terms on the end together. So negative 5 over 2x plus y equals, how do I do this? Well, I need a common denominator, so I'll have negative 15 over 2 plus 8 over 2. And then I can put those two numbers together, right? Negative 15 plus 8, that's going to be negative 7 over 2. And then this stays the same. Remember, I don't want the coefficient in front of my x to be a negative or a fraction, really. So I'm going to multiply everything here by negative 2 to get rid of those. If you do that, you'll get 5x minus 2y equals, well, what's negative 7 over 2 times negative 2? Well, the 2's and the negatives are going to cancel. You're going to be left with 7. This is looking now a lot like my standard form, right? So that would be my final answer. Okay, let's go to the next one. Number 6. Let's say I have 3x plus 4y is equal to 10. So clearly this one here is in standard form. And let's say I want to turn it into point slope form. So how could I turn this into point slope form? Well, first what we're going to need is a point, right? And I think the easiest point to find might be the x-intercept, or it would be like one of the easiest points to find is the x-intercept. So we're going to find the x-intercept. And how do you do that? All you have to do is set y equal to 0. So 3x plus 4 times 0 is equal to 10. This term just turns into 0, so you're left with 3x equals 10. Therefore, x equals 10 over 3. Therefore, we have the point 10 over 3, 0. That's our x-intercept. 10 over 3, 0. So now we have a point on the graph. What else do we need? Well, we need the slope. What's nice about finding the slope from standard form is that your slope is going to equal negative a over b. It always equals negative a over b. And if you look at your a and b values, our a is 3, our b is 4. So your slope is going to be negative 3 over 4. That's a nice trick when it comes to standard form that you can remember. Of course, if you wanted to, you could also find the y-intercept and then find the slope between those 2 points the way that we normally find the slope, right? Rise over run. But of course, this is a lot quicker and easier, right? Now that we have this information, I can say, all right, I want it in the form y minus y1 equals m x minus x1. Okay, let's just plug in what we got. Y minus 0 equals negative 3 over 4, x minus 10 thirds. Again, the 10 thirds and the 0 came from this point up here that we had, right? We found that point on the line, so we just plug in that point. Because again, any point can go here that we want. And this is your final answer. Okay, one more question. Let's say we're given something like 3x plus 4y equals 12. This is in standard form. Of course, hopefully we're used to seeing a standard form by now, right? Something x plus something y equals something. And let's say we want to put this into the intercept form or the double intercept form, right? The one that looks like x over a plus y over b is equal to 1, where a is your x-intercept and b is your y-intercept. How would we do this? Well, what I would say is let's divide both sides by 12, and the reason I want to do that is because I want the right side to become 1. So let's divide everything on the left by 12, and I'll divide the right side by 12 as well. What do we get? Well, you'd get x over 4, because 3 over 12 reduces to 1/4. You'd get y over 3, because 4 over 12 reduces to 1/3, and then you'd get 1 right here. So now we know the 4 here is your x-intercept, the 3 is your y-intercept, right? And now we have it in our intercept form. Now if you're wondering how this works or why it works, if you were going to try to find the y-intercept, you'd be setting x to 0, right? And if you set x to 0, that first term would disappear. Here, we can actually write it out. If you want to find the y-intercept, you would set x to 0. So if I have that standard form to start with, I'd have 3 times 0 plus 4y equals 12. This term would disappear because it's multiplied by 0. You're left with 4y equals 12. Divide both sides by 4 to solve for y, and you get y equals 3. You could do the exact same thing to find the x-intercept, right? Set y to 0, do the same process, and you'll get x equals 4. That's why the math checks out here. That's why it works. So there are numerous ways that you can represent these equations, but mathematically they all check out right? They all mean the same thing. It's just that algebraically they've been messed around with a little bit to be put into a different form. But as you've seen through all these examples, we're able to switch from one form to another just by using our algebraic skills and moving things around.